Alright, so welcome back to the OneClass channel. Again, my name is Joey. I'm going to be your math teacher for this session. So here at OneClass, what we're doing or what we're aiming to do is that we are creating these live streams and videos of basically solutions of frequently asked problems. So these problems basically range from chemistry and mathematics in both the secondary level and also in the university and college level as well. And what we're doing here is that what the teachers here at OneClass are verifying these solutions so that you have the best answers moving forward in either assignments, your tests, or your other future courses. So again, my name is Joey. I'm currently a secondary school educator in Ontario. My subjects that I can teach confidently are chemistry, math, and music. And yeah, hopefully in this next hour, what I'm going to do is I'm going to focus mainly on some grade 9 algebra, some pre-algebra, and some algebra 1 types of questions. And we'll hopefully be able to answer 11 questions on these topics as well. So let's get started on today's problems. So what we have here, our first question of the day is asking us, it's a geometry question. So what we have here is we have an ABC type of triangle, and it's similar to AEF by the side similarity theorem. So again, very typical geometry question here. So we have two triangles we have basically a triangle within a triangle. We have this big triangle ABC, and then we have a smaller triangle AEF, and both of these guys here are similar. So when we talk about similar, we're talking about these triangles are similar because of side similarity theorem, which states that these sides here are proportional. All three sides are proportional to each other. So if we know that, then it's asking us which ratio is also equal to AB over AE and AC over AF. So let's look at the side. Let me write this down first. So side similarity theorem. And this guy, side similarity theorem, what it means is that, again, if we have, if basically all three sides, if all three sides, or all three pairs, of corresponding sides, pairs of sides of two triangles are proportional, then two triangles are similar. So we're saying here that AB here, you can maybe think of a ratio here as half, because that's what I can visually kind of see, right? So AB here, half of AB is AE, half of AC here is AF, and then BC here is half of EF, right? So it's asking us what is similar, what ratio is also equal to AB over AE. So let me write this down first. So I have AB over AE, and that's equal to AC over AF, which is equal to some type of proportion or some type of ratio. So let me look at these two guys first. So I have AB over AE, right? I have AB over AE. So this is, you can think of it as 2 to 1, 2 to 1 ratio, right? You can think of AB as twice as long as AE here. So you can think of this as a 2 to 1 ratio. AC here is also twice as long as AF here, right? So again, we're focused on this side here and this side here. And as you can see, the longer side is first, and then it's the smaller triangle. So the bigger triangle and then the smaller triangle, the bigger triangle and the smaller triangle, or the bigger side. Sorry, the bigger side and the smaller side, the bigger side and the smaller side. And what we want to know is which ratio is also equal to these guys here. Well, it has to be a ratio of this last side here, right? And again, it says if all three pairs of sides of two triangles are proportional, then the two triangles are similar. So therefore, if I already have a ratio for one of these sides here and one of these sides here, I need to think of a ratio to cover these guys here, right? So it says I want the bigger side first over the smaller side. So I'm going to put this, the answer would be CB, which is the longer side here. So CB over this guy here, which is EF, right? That's the smaller side here. So again, the bigger triangle ABC versus the smaller triangle AEF. Again, the bigger side over the smaller side here is the ratio. So therefore, D is our correct answer. Right? CB over EF is our correct answer here, based on side similarity theorem here, or SSS similarity theorem. As you can see here, the answer is also correct. So option D is correct. That's good. So because it's similar, therefore the corresponding sides are proportional. That's great. So therefore option D is correct. A here is false because EF over BC here, EF over BC here would be half of the proportion here. It's just simply flipped, right? We wanted the bigger side over the smaller side. This one has a smaller side over the bigger side, so that ratio is incorrect. Option B is CF over AF. So CF over AF here is a 1-to-1 ratio, right? A to F and F to C are exactly the same lengths. Same with A to E and E to B here, right? These two are also the same lengths here. So they're not proportional to the bigger triangle. So therefore, option D here is correct. So the solution here is correct. Good analysis. Okay, number 2 is asking what information is necessary to prove two triangles are similar by the Sas Similarity Theorem. So I want to prove two triangles are similar by the Sas Similarity Theorem. So what does Sas Similarity Theorem mean? Well, it means it's side angle side, right? So this guy here is different from what we had before. Our question was side side. This one here is side. S here stands for angle, and then it's side, right? So I'm going to have a side similarity theorem. And what does that mean in the first place? And let me kind of write down the formal definition of this theorem here. So it says if an angle of one triangle is congruent, so the same, to the corresponding angle of another triangle, and the lengths are proportional, so plus the lengths of that was a bad plus lengths of these sides are proportional, triangle is similar. So what does that mean? So when we look at these two triangles here, and they kind of drew this out already, which is great, but I'm going to draw it out again. So I'm going to draw a triangle here, and maybe a smaller triangle here. And what it means here is that if I have this triangle ABC, so ABC, so there's angle and then DEF. It's asking us if I have an angle between A and B, or angle B here. If angle B equals angle E here, and if the two sides here, A and B and D and E, are proportional, so if I can say here that A and B, if A and B over B and C, over B over C here, equals DE over EF here, or you can flip this and the reciprocal will be true, then these two triangles are similar, right? So therefore, if I'm asking us if these angles are the same and I want the sides to be the same, I need these two pieces of information to be true to prove similarity. So these two things are the answer here to prove similarity using, writing's not that great today, sorry, using Sas theorem. So let's look at the answer here. And it says here side angle side, which is good. Two triangles would be similar if they're able to show that two sides of the triangle ABC are proportional to two sides of the triangle DEF. So then ABC would be similar to DEF, right? So we can say that if we have ABDE, so AB over DE equals BC over EF here, and this is what I have as well, right? Then we could surely say that the angle, that the triangle ABC is similar to DEF here. So this here is correct. So this solution here is correct. And again, they use the two sides here, AB and DE, and BC and EF here, or technically the four sides, but both sides are proportional to each other, and the angles here are the same. So this solution here is correct. Good analysis as well. Number 3, how many pints are in a quart? So again, with how many pints are in a quart, we are working in the imperial system. And is measuring volume, right? Or how much something in terms of if it's a liquid, for example, like water, how much space it kind of takes up in terms of volume. So we know that if we want to solve this solution, we need to, or solve this problem here, we need to know some basic conversion factors. So we know that 1 gallon here equals 4 quarts. 1 quart here equals 2 pints. And finally, 1 pint here equals 2 cups. And we actually don't even need to write down the other conversions here because I have this solution. This conversion factor is already going to provide us our solution, right? So it says how many pints are in a quart? Well, this answer kind of gives it, this conversion factor gives it away, right? In 1 quart, I have 2 pints here. So that's going to be our solution. There are 2 pints in 1 quart. So the solution here is correct. There are 2 pints in 1 quart. And that is our solution here. So again, we don't need to do any math for this one because it's given right in our conversion factor. So we don't actually have to use a unit analysis in this case. Okay, number 4. What is 0.75 as a fraction? So in order for me to convert, this here is a decimal, right? This guy here is a decimal. I have a decimal place like so. So how do I convert this? Well, I know that this here is I want to go from a decimal to a fraction, right? So first, all I'm going to have to do is I'm going to actually analyze this decimal here. So this decimal contains 3 places, right? Or in this case, 2 places. This guy here is our whole number, and then 0, so we don't really care about this guy. So this guy is our whole number, and it's not part of the decimal places. So here's our whole number. This guy here is our tens digit, and this guy here is our hundreds digit. Let me write this on top actually, so you can see it better. Our tens digit. Here's our hundreds digit. So if I want to write it as a fraction, so 0.575 as a fraction, this is going to equal, as you can see, I have 2 decimal places and I have a digit in my hundreds digit. So therefore, my denominator is going to be 100. And then that's to figure out the denominator to just basically see the last digit and see what place it holds in the decimal. And then we are going to look at the numerator, which is simply just the decimal itself. So in this case, it's 75 here. So we're taking everything that is the 2 decimal places that exist after the decimal. So we have this as our fraction here. And what we can do is we can actually reduce this to lowest terms, right? So this is going to equal, we reduce to lowest terms. We can say that we're looking for a common denominator between 75 and 100. In this case, I would look at, actually, I know that 25 here is a greatest common factor because it goes into 75 and it also goes to 100. And the only reason why I know this is because I'm thinking of this in terms of money. I have 3 quarters
is going to be 75 cents, and 4 quarters is going to be 100. So I know that this here is divisible by 25. So therefore, the fraction here is 3 over 4. So 3/4 is my fraction reduced, is 0.75 as a fraction reduced to lowest terms. So the solution here is correct. It says here in the given case, you have 0.75. It's converted to 75 over 100, which is equal to 3 over 4. So this solution here is correct. It's a good analysis as well. This is number 4. Number 5 is asking us how many feet are in 13 miles. In 13 miles. So again, this here is, again, we're working in the imperial system, but this is talking about length, right? Not volume, like in the previous question. And this here is measuring length. So again, we need to know some important conversion factors, right? So we have 1 mile here equals 1,760 yards. And we have 1 yard here. It's going to equal 3 feet. So we're going to do some unit analysis here. And we have to be able to, to figure out how we have to basically use unit analysis and use this concept of use that concept to figure out how many feet are in miles here. Because again, if you look at our units here, we have miles here, and it doesn't directly equate to feet, right? It equates to yards first, and then it's going to equate to feet. So what we're going to have to do is we're going to have to do something called dimensional analysis. So again, we need how many feet are in 13 miles. So again, we're starting with 13 miles here. Write this down here. We're starting with see if pen works. There you go. So I'm starting here with 13 miles, right? So I'm writing down to 13 miles. I'm going to multiply that by how many miles do I know? How many yards in a mile? I know for a fact that I have 1,760 yards per 1 mile, right? And then I want to figure out, okay, how many yards are in feet? Well, I know that I have 3 feet in 1 yard, right? So I can say that I have 3 feet here in 1 yard. And as you can see here, these units are going to start to cancel out, right? These miles start to cancel out here. These yards start to cancel out here. So therefore, I'm only left in feet, and that's the unit I want to solve, right? So this is called dimensional analysis or unit analysis. Unit analysis, and it's actually very, very useful, especially in physics, where we have many units to work with. This is a good tool to help us see which units we get at the end. So all we have here is 13 times 1,760 times 3. Okay, it's divided by 1, so it doesn't really do anything in terms of math. It doesn't really give us anything when we divide by 1. But what we have here is we get just the same number, right? So we get in total 13 times 1,760 times 3 would get me 68,640 feet here, and this here is my answer for this problem. 68640. And as you can see, this solution is also correct. 1 mile here equals 1,760 times 3 feet, right? So there's going to say 13 miles equals 13 times 1,760 times 3 feet. And they exactly did what I did here. 13 miles times 1,760 times 3 feet. Although they didn't really include the units here, but it's totally fine. They just did it based off this table here. So this solution here is correct. It's a good analysis as well. Okay, number 6. This here is another unit analysis problem. This one is slightly harder in terms of unit analysis, but it's asking us how many cups are in 12 gallons here. And again, we are in the empirical system. And it is measuring volume. So we know these guys here, and we know that our we know our conversion factors, right? Well, when we have 1 gallon equals 4 quarts, we know that 1 quart equals 2 pints. 1 pint equals 2 cups. So I want to figure out how many cups are in 12 gallons. So as you can see, we can't convert directly from gallons to cups. We got to go through a specific step, right? So what we're going to do is we're going to use it as this concept again of unit analysis, right? Basically the same thing as what we were doing in the previous question. So what do we have first? Well, we're going to start here with 12 gallons, right? We're starting with 12 gallons, and we want to find out how many cups, right? So let's write this down. We're starting with 12 gallons. I'm going to multiply that by how many gallons and how many quarts in a gallon? I have 4 quarts in 1 gallon, or over 1 gallon. And then multiply that by how many pints are in a quart? Again, it says here 2 pints in 1 quart. And then I'm going to multiply that by how many pints, how many cups are in a pint? Well, I have 2 cups in a pint, right? So 2 cups in 1 pint. And once I see this unit once I see this unit cup here exists, I can stop, right? I can stop my unit analysis because I want to, again, it's asking how many cups are in 12 gallons, right? So again, units here are going to cancel out. Gallons cancel out with gallons. Quarts cancel out with quarts. Pints cancel out with pints. So I'm left with cups here, and this is our unit of interest, right? So let's do the math here. It says 12 times 4 times 2 times 2. 12 times 4 times 2 times 2. It will give us 192 here. Again, if you're not given a calculator, what you could do is you could do 12 times 4 here is 48 times 2 times 2. 48 times 2 here is 96 times 2. And then 96 times 2 is 192 here. So it depends on if you have a calculator or not here. But this guy is going to give us 192 cups. And this here is our answer for this problem here. And let me look at the solution. As you can see here, it also says 192, which is great. And it says here 12 gallons times 4 quarts in 1 gallon times 2 pints in a quart and 2 cups in a pint would give us our answer as well. So this solution here is correct. Good analysis as well. And then we have this here is our next problem here. This is number 7. So number 7 is how much is 90 degrees in Fahrenheit? How much is 90 degrees Celsius in Fahrenheit? So what we're going to do is what we have to figure out is we have to figure out this relationship between these two things, right? And this here is a unit of temperature. From Celsius to Fahrenheit, these are all units of temperature. And what we need to do is we have to figure out a formula to calculate, to convert Celsius into Fahrenheit. So usually you're given this formula here. The solution also gives us this formula, which is great. So again, it says here C here, which is our Celsius, equals 5/9 times the Fahrenheit minus 32. So what we're going to do is we're given this algebraic expression here, and we want to figure out Fahrenheit, right? And we're given our Celsius. So we have to rearrange our formula to figure out for our Fahrenheit. So let's do that. So in order for me to do that, all I'm going to have to do is I have to multiply both sides here. if I want to bring 5 over 9 over, I'm going to multiply both sides by 9 over 5, right? So I can multiply this side by 9 over 5, this side by 9 over 5. So these guys cancel out, obviously, and I'm going to be left with this here is 9 over 5 times c equals f minus 32. And then all I have to do is just move this 32 to the left side here. So 9 over 5 c, and then we add both sides by 32 here, and this is going to cancel out, and it will give me f. Or I can write this and flip the sign and say f here equals 9 over 5 c plus 32. Now, once I'm given this, I can plug in my Celsius, right? I have 90 Celsius, and I want it in Fahrenheit. So 90 Celsius is obviously a C kind of term here. So F equals 9 over 5 times 90 plus 32. F here equals 9 over 5 times 90. So you can think of this as I can cancel out this 5 here, and then cancel and divide 90 by 5 to get me 90 divided by 5 would give me a number of 18. So this here is 18. I'm doing now 18 times 9 here, which would give me a value of 162 plus 32. And then this f here equals whatever 162 plus 32 is, which is 194. So if we want to convert 90 degrees to Celsius, this here is 194 degrees Fahrenheit here. And as you can see, the solution is correct. F here equals 194. So therefore, or maybe I'll write my therefore statement here. Therefore, 90 degrees Celsius equals 194 degrees Fahrenheit here. And this solution here is correct. It's correct. Go to analysis. That was number 7. Number 8 is asking us 20 centimeters to inches. So I'm converting, I guess, again. Lots of conversion questions today. So convert 20 centimeters to inches. And again, these guys here I actually have two different systems. I have centimeters and I have inches here. So I have both the metric, which is the centimeters here, and the imperial system. And I'm both measuring length, right? So these two are, it's two different systems. So if I were to convert between two different systems, I definitely don't, I need to know a conversion factor between those two guys here. So as you can see from the solution here, 1 inch equals 2.54 centimeters. And this is relatively well known. If you don't know this conversion factor, it's probably going to be given to you on a test. I don't expect a lot of teachers to just ask you to memorize conversion factors just because they are pretty useless, to be honest. You can always just Google them and you can figure this answer out here. So it says here 1 inch equals 2.54 centimeters. So if I want to find 1 centimeter, this will simply equal 1 over 2.54 inches, right? And if I were to do a decimal here, I could use my calculator and do that decimal here. 1 divided by 2.54 is 0.3937 here. 3937. And I'm only going to round to to 4 decimal places, just for the sake of simplicity here. This is inches. So knowing this conversion factor, I can simply just plug in our 20 centimeters, right? So 20 centimeters I want to convert it into inches, right? And I know that in 1 inch, there are 0.3937, right? So in 1 inch, there are 0.3937 inches in 1 centimeter. And this will equal, again, I want my inches as my last conversion. Centimeters here are going to cancel out. So I'm simply doing 20 times this conversion factor, which will give me a value of 7.87. And this here is going to be my answer for this problem. 7.87 inches is 20 centimeters in inches. And as you can see here, the solution is also correct. 20 centimeters equals 7.87 here. So I can write a therefore statement and say Therefore, 20 centimeters equals 7.87 inches. So the solution here is correct. Good analysis here. Number 9. 3 more questions for the day. So just above our halfway point here. Question 9. It's asking us, draw the graph of f of x equals 0.5x plus 3 minus 4. Okay. So I'm going to say graph f of x equals 0.5 times x plus 3 minus 4. So before we graph this function here, I could actually simplify this algebraic expression, right? I have f of x equals 0.5x, and this here I have this plus 3 minus 4 here. I can actually do this operation in the brackets, right? 3 minus 4 here is simply just -1, so this here would equal -1, right? So f of x equals 0.5x minus 1 here. So what we have to do when we're graphing this solution here, we could actually change f of x here into y, right? Just to for our purposes here. Let's change this to y. And what we're going to do first is we can solve for some intercepts and whatnot, right? Well, we know here first is that this already is in slope y-intercept form, right? This guy here is our slope, and this guy here is our y-intercept, right? So we know these guys already exist. So what I have to do next is I want to solve for my x-intercept, right? So these are all components we need before we graph. So if I want to solve for our x-intercept here, what I'm simply going to do is I'm going to set y to 0, right? So I'm going to say that, so this is set y equals 0. So I'm going to say if y equals 0, then I have 0 equals 0.5x minus 1. And then I can simply move, and then I'm just algebraically rearranging for my x value now, right? Because I'm solving for the x-intercept. -1, I can move this over to the other side to make this +1. So this is +1 equals 0.5x. And I can divide both sides by 0.5, right? So 1 over 0.5 equals x. So therefore, you can say x here is going to equal 2, right? So this here is going to be our x-intercept for our graph. This here is our, I'm not going to box this because this isn't our answer yet, but we have our x-intercept as well. So I can say here x would equal 2. And finally, now we can graph, right? We're given three types of information, so we can probably graph. So I'm going to sketch this graph, and I'll actually show you on Desmos what this graph actually looks like without the sketch. So I have here my intercepts here. I have, again, -1 is going to be my y-intercept. So let me write out -1 here. Y is here is x guy. This is -1. And my x-intercept here is 2, right? So I'm going to say 1, this here is 2. So it's going to come, I know I have a point here, also a point here, and it's going to be negative, this here is -5, right? -0.5. Or no, sorry, it's positive 0.5 is our slope, right? So you can think of ours as our slope, it's increasing by 1 over 2. So you can say I'm going up by 1 and then over by 2. So these 2 points are correct. So my next point would be up by 1, which is at 1, and then right by 2, right? So this would be 3, 4. So my next point would be kind of, here. So remember this, you can think of our slope here. Our slope is really important, right? If 0.5 is our slope, you can also convert this to half. This here is our rise over run. So when we talk about rise, our numerator here is rise. So we go up by 1, and then we go, our run here is either left or right by 2. In this case, it's right because I have a positive slope. So this solution here is correct. I have 3 points in my graph now, so I'm simply just going to draw a line from here to here. And this will connect, hopefully, all of these points here. And this here is my graph of, this here is f of x. this is the graph of f of x equals 0.5x plus 3 minus 4 here. And what I'm going to do is I'm going to bring out Desmos, and I'm going to verify this graph for you as well. So let me bring out Desmos for us. And this, if you don't know who a Desmos is it's actually a graphing kind of a calculator, and it helps you visualize functions here. So I usually do use this to just check my answer and to show you with colors what this function looks like. So f of x here, I'm going to type in 0.5x plus, and then bracket 3 minus 4, right? And as you can see, this here is our graph, right? So here's our beautiful graph of 0.5x plus 3 minus 4, or you can say simply 0.5x minus 1. And as you can see, I can visualize these 2 points, right? These 2 points here are 0 and negative 1. And like my graph here, I have this point is also 0 and negative 1 here. And this here is 2 and 0. These two are my intercepts here. And as you can see, the next point, like I've chosen here, would have been 1 and 4, right? So let me maximize in for you. 1 and 4 here would have been my next point here. This is 2 and 0. This is 0 and 1. So as you can see here, this solution here is correct. So the graph here is very, very accurate. And again, it matches my Desmos graph here. So this solution, let me draw this out here. This solution looks correct. 0, 1, 2, 0, and this is 0.5 minus x here. So this solution looks correct as well. So solution is correct. Good analysis here. We'll leave this page as well. Don't need Desmos anymore. I'm going to do 2 more questions for the day, number 10 and number 11. It's asking us to write 6 over 11 as a decimal and a percent. So write 6 over 11 as a decimal and percent. So let's change. We're doing 2 different operations here, right? So let's do one first. Let's do this first one here. We want a fraction into a decimal, and then into a percent, right? So let's do this operation first. We have to do this first operation before we can do the second one here. So let's do this one first. We're converting into fraction into decimal, right? So in order for us to do that, we're simply just using this concept of long division, right? So we have 6 over 11 here. Our denominator of this fraction is going to become our divisor, and 6 here is going to become our dividend. And I'm going to write some zeros here to help us divide here. And we're going to simply just do long division. So again, we have 11 times what number is closest to 60. 11 times 5 here is going to equal 55, which is pretty close to 60. And then, again, I have my decimal here. This is my decimal here. And then this, you can write a 0 here as well. So 60 minus 55 here is 5. Bring down the 0 here. So 50 here. What is closest to 50? Well, 11 times 4 is 44, which is closest to 50 without going over. So 4 times 11 here is 44. Minus that would give me 60 again, or 6 again. And then I bring down the 0. And then 11 times what number is 60? Well, 11 times 5 here is 60 as well. So 5 times 11 is 55. 60 minus 55 here is 5. And bring down the 0 again. And then as you can see here, it actually repeats, right? 11 times this is 4 again. So it's actually going to be, it's going to not be a nice decimal. It's going to repeat. 0.54 is going to repeat. So it's 0.54, 54, 54, 54, etc., etc. So this point here, again, they did long division as well. And this solution here is correct, right? So in decimals, you can say therefore 6 over 11 equals 0.54545, and then you write these ellipses to say that this fraction here is repeating. So this here is my solution for the first part of the question, so writing it as a decimal. And then what I'm going to do is I'm going to write it as a percent, right? So how would I write this as a percent? Well, if I'm given my decimal here already, I can easily change this into percent, right? So I have 0.5454. And then what I want to do with percentage, if I'm giving a decimal, I want to always multiply by 100%, right? Multiplying by 100%, I will get my percentage here. So if I'm multiplying any decimal by 100, I simply have to shift the decimal one place and 2 places to the right here. So this will be my new decimal point here. So therefore, this is 54.54% here. And this solution here is my answer here. So therefore, 6 over 11 equals 54.54%. And these two are my solutions for this problem. So 6 over 11 equals 0.5454, like given so, and percentage is 54.54. So this solution here is correct. It's a good analysis as well. And then finally, my last question of the day would be number 11. Is asking us how many cups are in a quart. And again, we are working in, this here is another measurement question, and it's going to be in the empirical system. And this is measuring volume. I mean, let me write it down in blue actually, because it's not part of the problem here. Okay, so again, we know our conversion factors already. Well, 1 gallon here equals 4 quarts, and this here we care about quarts and we care about cups, right? So we have to actually write the other conversions as well. And I know 1 quart equals 2. Sorry, this is 2 pints, not 2 cups. So that 1 pint equals 2 cups. So given all these guys here, it's asking us how many cups are in a quart. Well, I have a quart here and a cup here, and it does not actually directly equal each other out. So I need to use this concept of, again, unit analysis, right? So I'm going from one thing to another thing here. So unit analysis. So how would I do that? Well, how many quarts do I have here? I only have 1 quart, right? So I'm going to say here, I have 1 quart. And I want to convert quarts here into cups, right? So I know 1 quart here it's going to equal, obviously, 2 pints in 1 quart. And then 1 pint here equals 2 cups, right? So in 2 cups, I have 1 pint. And the trick here with unit analysis is that we want to always cancel out our units, right? I want to always put the pints here with the pints here and the quarts here with the quarts here, right? I always want to put it 1 in the numerator and 1 in the denominator. So I wouldn't write something like this, and I'll just red. I wouldn't write multiply by 1 pint over 2 cups here, because then I would have pints and pints on top, and it's not going to cancel out here. So that's just a side note here. Quarts cancel out, pints cancel out. So therefore, the math becomes very simple, right? Because cups here is by itself. So I simply have 1 times 2 times 2, which equals 1 times 2 here is 2 times 2, which equals 4 cups here. So 1 quart equals 4 cups. 1 quart here equals, there's 4 cups in 1 quart. So I can say that, therefore, there are 4 cups in 1 quart. And as you can see, this solution here is correct. Again, in a quart, there are 4 cups, and they did the exact same thing as I did, right? So they did kind of unit analysis as well. They said 1 quart here is 2 times 2 cups. So again, it's multiplying by this 2 here, 2 pints over 1 quart, and 2 cups over 1 pint here. So that's 2 times 2, and it's going to give us 4 here. So the solution here is correct. It's a good analysis as well. So that's the end of this video. Again, I did 11 questions in basically the pre-algebra, the algebra 1, and the geometry type of questions here. Stay tuned if you like these videos. Definitely stay tuned to my next stream, which will be in about an hour. I'm going to do much harder problems in basically grade 10 to 12 math. So this is if you're tuning in from the US, this would be the end of algebra 1, algebra 2, and also pre-calculus questions. So you can definitely tune in for those problems as well. And again, if you like this material, and if you like these videos, or if you like me, definitely check out our YouTube channel at youtube.com/OneClass, and you can find out all those videos of this live stream and also other past live streams as well, if you want to go back and look at these videos here. So again, thank you so much for watching. Stay safe, stay healthy, have a great day. Take care.